Recently, sustainability has been at the forefront of research journals, government reports, and consumer product labels, and rightfully so. While materials such as polymers and electronics have revolutionized the day to day life of the world's population, making refrigeration, electricity, and heating a possibility, they have also entrained an exponential increase in material consumption. As the world population increases, we are consuming more raw material than ever before, reaching 13 tons per person and 100 billion tons annually. This consumption has quadrupled since 1970, while the global population has only doubled. While this increase in consumption is alarming, what should strike even more concern is the fact that just 8.6% of these utilized materials see a second life through recycling. To mitigate the amount of waste entering our environment annually and to meet the Paris Agreement goals of CO2 emissions reduction, it is imperative to change our consumption habits. Faced with this issue, scientists and engineers of dominant materials consuming industries such as construction, textiles and fast fashion, and polymers are focusing on the development of sustainable materials. Sustainable materials are defined as having no negative impact on the environment. They do not lead to any of the depletion of non renewable sources, nor do they cause any harm to humans and society through their lifetime. Material usage in the construction industry accounts for nearly 40% of the total harvested amount, and steel and cement production accounts for 15% of the worldwide greenhouse gas emission. Developments in these materials production are seeing that these emission number can be reduced. In the case of cement, scientists are optimizing concrete mixes to reduce CO2 emissions without compromising on strength. This has already yielded a widely used concrete mix in Europe, which presents strength comparable to standard mixes, but with 20% reduction in carbon emissions. As for steel, recycled steel is now sometimes used and processed through renewable energy sources, as is done in Colorado Steel Mill. Construction materials made of alternative sources are also being explored. Mycelium offers a versatile working material with the potential to replace consumer packaging. Already, this derivative of mushroom plants has been developed to boost material properties comparable to styrofoam, meaning that it can provide equal thermal insulation as standard food takeout containers while also being bio based and biodegradable. However, its development requires both more time and energy for production, thus reducing its market competitiveness. The textile and fast fashion industries are significant polluters given the short lifetime of most items. Since 1980, clothing purchases have increased fivefold, with the average clothing garment only being worn 7 times in its life. Traditionally, a very few regulations pertaining to emissions and sustainability have prevented companies pursuing these avenues of succeed financially. Recently, however, new regulations are being set in place. France announced this July that all clothing article made within its border must have a tag which details precise climate impact, allowing for consumers to be more aware of the impacts of their shopping has. Sustainable materials, which may one day become more prevalent in the fashion world, include again mushrooms such as Adidas Stan Smith Milo shoe made from mycelium based fabrics or even recycled cottons. Finally, polymers are an integral part of our modernized society, but are tied with poor consumption habits. Sustainable polymers are a growing field in research, and promising advances are being made. In contrast to traditional polymers, which are derived from non renewable petroleum sources, sustainable plastics are produced from plants growth through photosynthetic processes requiring water and carbon dioxide. This makes them less energy intensive to produce and less carbon emissive. Sustainable plastic can also be composted through thus releasing carbon dioxide, dirt, and water, which allow for the regrowth of plant and subsequent polymer development. However, a major reason sustainable polymers are not commonly seen on the market is because they are relatively weak when compared to traditional counterparts. It is globally agreed that our current material consumption habits must change, but conflicts arises as to how to approach it. Major opponents against the development of new green and sustainable materials argue the focus should be more on developing better recycling processes rather than material. By developing new recycling processes and techniques, the life cycle of already manufactured products could become a closed loop, allowing them to be repurposed and reused. Additionally, labeling items as sustainable provides justification for overconsumption of the item and greenwashing. Moreover, it can be misused on the item which do not fit the actual definition. For this reason, opposing views on sustainable materials also argue more focus should be put towards educating the consumers on the energy demand of said sustainable materials and on a push towards simply consuming less as a global society. Going forward, it will be imperative that sustainable materials becomes the norm. While reducing the consumption and improving recycling will ease the burden our society has on the earth, it is unreasonable to expect no new materials to be manufactured. Thus, developments in truly sustainable materials, proper marketing, and educating consumers on the impact of their choice will be necessary if greenhouse gas emissions are to meet the goals of the Paris Agreement.